In this short lesson, we're talking about two very special right triangles. In fact, they're so special, they show up in your math chart. The first triangle is the 45, 45, 90 degree triangle. Now, you may notice that we have two angles that are congruent. This is actually an isosceles right triangle. And the theorem says that in this triangle, both legs are congruent. And the length of the hypotenuse is the length of the leg times the square root of 2. Now, why is this true? So I'm going to go ahead and set up a right triangle with legs of 1. And how do I know, if this is an isosceles right, how do I know that both those angles are 45? Well, I could say that there's 90 degrees, and every triangle has 180 left total. That leaves 90 left over. So each of these base angles have to be the same. They split it, so they're both 45. So any isosceles right triangle is 45 and 45 for the base. Now, I'm going to go ahead and try to find out how long the hypotenuse is. Well, I just substitute using the Pythagorean theorem. C squared equals 1 squared plus 1 squared. And I end up with the hypotenuse being the square root of 2. Now, as you can see, this looks a lot like the triangle up here. And in fact, when you're writing down the triangle from your math chart, you can replace those x's with 1s. So you can say square root of 2, 1, 1. And that makes your life a lot easier. And basically all 45, 45, 90 triangles are similar. And you can almost treat this x like a scale factor if you wanted to. The other special triangle is the 30 degree, 60 degree, 90 degree triangle. And in that one, it has a nice relationship. The length of the hypotenuse here is twice the length of the shorter leg. And then the length of this longer leg here is the length of the shorter leg times the square root of 3. And if you were to substitute 2, 1, and square root of 3, 1 and square root of 3 will give you 2 using the Pythagorean theorem for your hypotenuse. These problems are actually really simple to solve. The most important thing is draw the appropriate special triangle using your math chart, except replace the x's with 1s. And then, so if you have 1 square root of 2 times 1 or 1 times square root of 2, you can just put square root of 2. Using the corresponding sides, go ahead and set up a proportion. And then finally, just cross multiply your proportion to get a simpler equation and solve. So our first example here, you can see I have 45 degrees and 90 degrees. The other angle has to be 45. So this is like my special 45, 45, 90. And I went ahead and drew it with the sides. The long sides, the hypotenuses, must be similar, and the legs must be similar. So I go ahead and set up a proportion, blue to green. X is to 14, as square root of 2 is to 1. Cross multiply, and you get 1 times x equals 14 times square root of 2. So x equals 14 times the square root of 2. And you can actually leave your answer like this. Unless we're asking for something to the tenths or you're having to fill in a griddable, there's no reason for you to actually plug this into your calculator. Now this next triangle, I'm trying to find the lengths of A and B, and I have a 30 degree angle and a 60 degree angle. Your math chart has that triangle on it too. I went ahead and I drew it. There's the square root of 3 and 2 and 1. And I made sure that this 30 degree angle here corresponds to that, so this square root of 3 corresponds to the A. So since I'm trying to find A first, and I know the numbers for both the red sides, I can say, oh, A is to square root of 3 as 11 is to 1. And I set up my proportion, cross multiply, and solve. A is equal to the 11 times the square root of 3. I can do the same thing for B. I'm going to do blue to red is as blue to red. So B is to 11 as 2 is to 1. Cross multiply, simplify, and B is 22. In example 3, we have two arms of a railroad side are perpendicular bisectors. That means they cut each other in half. And in fact, they mark both lengths here as 19.5 inches, so you know that they're equal just by the way they mark them. They're trying to find this distance labeled D, and they want us to round the answer to the nearest tenth of an inch, so we won't leave the square roots in it. First thing I do is since this is an isosceles right triangle, this is a 45, 45, 90. I draw the original, and then I draw the one from the math chart with the ones in for x's. So I can set up a proportion. Blue, I've got my blue d and my blue square root of 2, both my hypotenuses. So I can say, in this case, I went green to blue. It says green to blue. So I have 19.5 is to d as 1 is to square root of 2. Cross multiply and solve. D is the same as 19.5 times square root of 2. And I want it rounded to the nearest tenth of an inch. So I substitute this in this calculator, and I get this long number, 27 and 577, and it continues on. Since I want the tenth place, I circle the hundredths, which is to the right. That's 5 or bigger, so I round up. 27 and 6/10 of an inch is my answer. In our last example, we're looking at a billiard ball rack, and it's got 15 billiard balls in it in the shape of an equilateral triangle. And you're probably going, wait a second. This was right triangles. Equilateral triangles are not right triangles. Well, let's keep going on and see how this works out. They do tell us each side of the rack measures 11 inches. What is the approximate height of the triangle formed by the rack? Well, since they asked us for the height, and the height always makes a right angle with the base, guess what triangle I just made? I have a 30, 60, 90 degree triangle. So I can find this x using a proportion with the original special triangle, square root of 3, 2, and 1. I'm trying to find x, so I'm going to go green to green. And I could either use the blue or the red. Red has a decimal, so we'll stick with the blue. So I can say x is to 11, blue is to green, as square root of 3 is to 2. Cross multiply, 2 times x equals 11 square root of 3, divide both sides by 2. When I substitute this into my calculator, because they want us to round to the tenth of an inch, you can see I get this long number, and then I underline in the tenths place, that's a 5. The next digit is a 2, so I keep it at 9.5 or 9.5 inches.